Howdy, howdy. This is the day 4 lesson for Unit 1. And today we're going to be talking about measuring segments. So I guess let's just jump right into it. So the distance, I don't want to write in green. I think I want to write in purple. The distance between any 2 points is the absolute value of the difference of the coordinates. So key things here: absolute value and difference. Now, what's something we know about distance? Would I ever say something like, I went -5 miles? No, I went 5 miles. What about, I wouldn't worry about saying I went +6 miles. No, I just went 6 miles. So these bars are absolute value bars. They're not ones or anything like that. They're absolute value bars. Distance is always going to be positive. Another way to think of it, if you're driving and you look at your odometer, which that's what tells you how many miles your car has on it. If you put it in reverse, let's say you're going to live on the edge today and you're not driving forward to school, you're going to drive in reverse because you want to sell your car with less miles on it. Well, will the mileage start counting backwards just because you're driving in reverse? No. So whether you're driving forwards or backwards, you're still moving. So distance will always be positive. Oh, and I guess I left out, in case y'all didn't know what difference meant, that means subtraction. So basically, take where you're at, subtract it from where you came from, that's how far you moved. So let's take that and apply it to our first example. They ask us to find the length of each segment. Remember, just as a little vocab review, remember a segment has a beginning and an end. So if we're asked about km, here's k, here's m. Now we're ending at m, so if I wanted to find the distance, I could say absolute value. What would we say m is? 3 point, looks like it's in the middle, so 3.5. That's where we ended. Where'd we begin? We began at 1. So 3.5 minus 1. It's going to equal the absolute value of 2.5, which is just 2.5. Now, just to prove that it doesn't matter whether you're going forwards or backwards, let's say I saw the 1 first, and so I'm just going to start with 1. That's the first number I know. I want to get something on paper, so I'm going to put a 1. minus my other number is 3.5. 1 minus 3.5 is negative 2.5. But if you take the absolute value of negative 2.5, you'll still end up with 2.5. So it doesn't matter which one you begin with, you'll still end up with the same answer. Either way, 2.5 is your answer. Okay, let's look at B. They give us this number line and ask us to find the distance between E. So I'm going to circle E on my picture so I know where it's at. And F. Again, let's circle F so we know where F is at. How do I find the distance? Well, I'm going to take the absolute value of negative 1 minus negative 4. Which negative 1 minus negative 4. Remember, if you have minus and negative, that's like saying negative 1 plus 4. So that's going to be the absolute value of 3, which is just 3. And there's our answer. Now, another way you may have learned this is what I call the bunny hop method. You start at 4 and you go 1, 2, 3. And if you want to do that, I'm not saying you can't. I mean, that's not really the mathematical way, but I said it. So. Okay, so now if you remember back to day 2, when we did proofs, we had something called the segment addition postulate. And we talked a little bit about it, but not much. Now we're going to talk a lot about it. So if B is between A and C, then we can say that if B is between A and C, it doesn't have to be in the middle, like exactly in the middle. It just has to be between it somewhere. We can say that AB, so the distance from A to B, plus the distance from B to C equals the distance, well, I went from A to B and then B to C. What's that the same as doing? Going from A all the way to C. So AC. Now, they give you this little way to remember. In case you don't want to remember the fancy name, just remember this little phrase down here. Part plus part equals whole. That's basically all we did here. Here's one part plus another part. So part plus part equals the whole shebang. Part plus part equals whole. Okay. So let's work some examples using this postulate. Now, if they don't give us a picture, we need to draw a picture. It helps you visualize it. I mean, if someone gave you directions on how to get to, I don't know, Mom's Diner or HEB, let's just say HEB. Let's say they didn't know where HEB was and they asked for directions. Would it be very helpful to just start naming, you come out of the high school, you take a left on Lufkin Avenue, and you drive all the way till you get to Timberland. They're just going to look at you and be like, okay, can you write that down for me? I have no clue what you're talking about. But if you say, okay, you're going to come out of here and go towards that bridge. Go under the bridge and go, and when you get to the light by Walgreens, you'll see HEB. Then they can start picturing, okay, I'm going to look for a bridge. I need to look for Walgreens. They say HEB is by Walgreens. So they start getting this picture in their mind because that's things they know of. Draw a picture, not in your mind, on paper. So, A, it says B is between A and C. Stop there. Draw a picture. There's A. All right, draw a line. There's C. It says B is somewhere in between. Okay. So I did that. Now let's read the next piece of info. It says A to C is 14. So if I go from A all the way to C, that's going to be 14. B to C is 11.4. Find A to B. That's what we're trying to find. Since we drew a picture, you're probably already thinking, oh, well, that's easy. Can't you just do 14 minus 11.4? Absolutely. So if you wanted to say 14 minus 11.4, let's see, what would that give you? 2.6? You could do that. That'd be your answer, 2.6. But if they throw an X in there, it's not going to be that easy. So let's set up an equation. Our answer is 2.6. But let's set up an equation. Let's call this question mark X. We know up here that part plus part equals whole. Well, there's a part, there's a part, there's our whole. So X plus 11.4 equals 14. What do you know? You subtract 11.4 from both sides, you get X equals 2.6. So, I mean, if there's not really an X involved, there's just numbers, you draw a picture, you pretty much can get the answer real quick. If there's an X involved, then you need to set up an equation. So in this case, we're going to have AB equals 2.6. Okay. I don't like that box. I'm going to draw me another one. Okay, so there's that one. Okay, so for B, it tells us S is between R and T. Now, it gave us a picture, so we don't have to draw that. It gave it to us. Find RT. We're finding RT. Which one of these lines is RT? Which one of these in our picture right here? Which one of those is RT? For X. So eventually, we'll need to figure out what 4x is equal to. Well, let's use our little formula up here. I wanted to go up, but not that far up. Part plus part equals whole. Here's a part. Here's a part. Here's our whole. So we're going to say 2x plus 7 plus 28 equals 4x. Now we've got to solve for x. Okay. First, though, we've got to combine like terms. Because I have a 7 and a 28. If this will quit moving on me, I have a 7 and a 28 over here. So if I combine those together, I get 2x plus 35 equals 4x. So let's subtract my 2x to the other side. And give me 35 equals 2x. Divided by 2, and I'm kind of out of room here. X is 35 divided by 2 is equal to 17.5. But notice here, it doesn't tell me to find x, it tells me to find RT. What do we know about RT? RT is equal to 4 times x. What do we know about x? X is 17.5. 4 times 17.5 is 70. So that means that RT has to be 70. Okay, so there's that example. Now let's look at congruent segments. We can tell that two segments are congruent to each other by these little tick marks. And what's congruent mean? What's this word right here mean? I'm going to put it in green. Remember, congruent means same size and shape. So in the diagram, since PQ is equal to RS, we can say that segment PQ, wrong color, PQ is congruent, segment PQ is congruent to segment RS. Now, what if I had two other segments over here? Let's say I had that segment and Okay, I would like to paste it. Hang on. Come here. I want to paste. Whoa, undo. Hang on, guys. Anyways, you'll still get the idea. Let's say I had these two segments and they had two tick marks on there. Well, that still means if I call this A and B, C and D, what that means is that these bottom two are congruent to each other, but not to the top two. So these are congruent to each other, and these are congruent to each other, but they're not congruent to each other. So we can't say that these two are congruent. Those two aren't congruent. But anyways. Okay. So let's go to the next page now. Flip over to the back. There's a reason we talk about congruence. That's because when we get to the midpoint of a segment, the midpoint of a segment bisects or divides the segment into two congruent segments. So bisects, that's just a fancy way of saying cut in half. That's all bisects means. Cuts it in half. So it cuts that segment into two congruent segments. If M is the midpoint of AB, of segment AB, let's draw that right quick. So I'm going to draw AB. There's A, there's B. M is exactly in the middle here. And since M is in the middle, what do we know about these two? They're congruent to each other. If M is the midpoint of AB, then AM has to be congruent to MB. So using our part plus part equals whole, AM plus MB equals AB. That doesn't change. What's new here is that AM is equal to MB. So if you're told something's a midpoint, then both of these hold true. A segment bisector is any ray, segment, or line that intersects a segment at its midpoint. Come back to me. Come back to me. Intersects a segment at its midpoint. So the way to think of this is to draw yet another picture. Let's say this is A, that's B, and I'm gonna draw a ray right here. That's point C, that's point D. Now, if I'm told that these A to C is congruent to C to B, that means that ray CD is a segment bisector. Okay. Next example, it says use the midpoints to find lengths. Draw a figure. We should be doing that automatically on these. Just automatically draw a picture. Unless they give it to you, draw a picture. It says B is the midpoint of AC. So I'm going to go and draw AC. AC. It tells me B is exactly in the middle. So that means AB is congruent to BC. Okay. Notice I'm taking it one little piece at a time. Like I did this first. I didn't read the whole problem. I just read, I'm like, oh, I can do something. So I did it. Now the next piece. AB is equal to 5x. I can do that. AB is 5x. Now the next piece. BC equals 3x plus 4. BC is 3x plus 4. Find AB. So what we ultimately want to get is AB. So we want to find this piece. Okay. Well, since we know that A to B is congruent to B to C, we can set these equal to each other. Because notice up here it says part equals part. So that's what we're using, this part equals part up here. So we're going to say 5x equals 3x plus 4. Now we need to solve for x. So let's subtract 3x. 5x minus 3x is 2x equals 4. Then we've got to divide by 2. So that means x equals 2. Are we done? Did we find what it's asking for? No. It's asking for AB. Well, what do we know about AB? AB is equal to 5x. We just found that x is 2. So 5 times 2, which is 10. Now we're done. AB is equal to 10. Okay, next one. It says if K is the midpoint of LM. Stop there. Let's draw it. I've got L, I've got M. K is my midpoint. Since K is the midpoint, that means each side is congruent to each other. Now, let's go on to the next piece. LK, so I did this, I drew it. LK is equal to 8. LK is 8. Now it tells us LM is 2x plus 9. So from L all the way to M, it's 2x plus 9. Find x. So in this case, we are finding x itself. Okay, well, what do we know though? We're not given the two parts, so we can't say part equals part. We can't set these equal to each other, which means we have to use the other one, part plus part equals whole. We've got to use that one. Well, I know one part is 8. I know the whole is 2x plus 9. What's my second part right here? Well, I know since K is in the middle, if L to K is 8, K to M has to also be 8. So that part's going to be 8 as well. Now let's solve. 8 plus 8 is 16. Subtract our 9. 16 minus 9 is 7. I'm out of room, so I'm going to come up here and rewrite it. Divide by 2. 7 divided by 2 is 3.5. That's going to equal x. Now, do we leave it like that? No, let's flip it. X equals 3.5. What does it ask us to find? X. We did it, so we're done. Okay, almost done. This next part's a little review for us. So this is what we did on the last lesson. We just have to name some things. That's it. Let's see what we remember. Okay, name one line. Well, I see 2 lines. We just got to name one of them. So, and there's multiple ways to name these. You only have to use 2 points on that same line. So if I wanted to say line LH, I could. That's a line. Now let's just say I'm an overachiever, which hashtag true story. I'm an overachiever. I can name the other line too. That one, I'm going to name KJ. Okay, next it says name one segment. So remember, a segment is between 2 points. So there's, again, several different options here. I see 6 options you can pick from. We're just going to do one of them. I'm going to say segment IL. Remember, on lines, like for part A, you put arrows. Segment, there's no arrows. Now it says name an array opposite of Li. Well, let's see where Li is going. Li goes up. So the array opposite has to start at L. We're going to start at L, but then we've got to go the opposite way. So remember, when you name an array, where you start goes first. I need a pen, not a highlighter. So we're going to start at L, and then we've got to go through H. And last but not least, name 3 collinear points. So 3 points that are on the same line. There's 2 options here. You could say K, L, and J. Or if you don't like that line, you can say I, L, and H. Okay, so that's our notes for day 4. Stay tuned for the guided practice for day 4.